Alright, so what's up guys? Today we're gonna be doing some practice problems for calculations with reaction enthalpies. So let's do one. How many kilojoules are released when 130 grams of Cl2 reacts with silicon, right? So let's just write 130 grams Cl2. We want to go from grams to kilojoules. So our next step would be from going to grams to moles, because then you could convert from moles to kilojoules. So in 1 Cl2, so in 70.9 grams of Cl2, there's 1 mole of Cl2, right? That's our ratio. And then our ratio to get Cl2, we have to do moles of Cl2. We have to do moles of Cl2, yeah. But it's not going to be 1 like I just did. It'll be 2 Cl2s. Per 2 Cl2s, there's 657 kilojoules of energy. So we just keep that. We cancel out these units. Oh, I forgot 2 moles. So these moles cancel out. These grams cancel out. And what we're left with is going to be in kilojoules. So blank kilojoules. We could do 130 divided by 70.9 K, then times 657 divided by 2, and those 130 grams of Cl2 are gonna be releasing 602.3 kilojoules. So we just write 602. Yes, let's go. We can erase that. 269 grams of PCl5. Same process, grams to moles. Let me just do the math real quick, or I'm gonna do the math with you guys. 30.97 plus 35.45 times 5. Open up our trusted calculator. 30.97 plus parentheses 35.45 times 5 equals 208. So per 208.22 grams PCl5, there's 1 mole of PCl5. Oops. 1 mole PCl5. And then per mole of PCl5, there's 67 kilojoules. 67 kilojoules. These units cancel out. These units cancel out the moles. And then we're left with blank kilojoules. So 269 divided by 208.22 times 67, 86.55. So that'll just be 87. Correct. Now let's just do some of this. 348 kilojoules are released. So when they're released, it's an exothermic reaction. Alright. So for this one, is this reaction endo or exo? If it's plus positive, that's gonna mean it's endothermic. So we could just put that. Correct. So how many kilojoules are required when 1.5 moles of SO3 reacts? They already give it to us in moles, so we don't have to do the mole to grams conversion. 1.5 moles of SO3, we moles of 2 moles of SO3 equals 790 kilojoules. This looks like a 8, but no, it's 0. So now our answer will be in blank kilojoules, and then we just solve in there. 1.5 divided by 2 times 790, 592.5. 592.5. That rounds to 590 kilojoules. And since because of the 0, it doesn't count. These are 2 significant figures. Yeah. So let's see here. How many kilojoules are required when 60 grams of O2 are formed? So for this one, we do have to convert to moles. 160 grams of O2, that's 32 grams of O2. There's 1 mole of O2. Let me see our equation right here. Per 3 moles of O2, 3 mole O2, there is, let me see our equation again, 790 kilojoules. 790 kilojoules. So our answer is going to be blank kilojoules. We just do the math from there. 160 divided by 32, 5 times 790 over 3. So that's gonna be 1316. So 1320 kilojoules. Boom. It didn't say how many significant figures, so I'm gonna count that right. How many kilojoules are released when 2.5 grams of Fe react? Let's do that real quick. I think you guys understand by now. 2.5 grams Fe, 5.85 grams Fe. There is 1 mole Fe, 1 mole Fe, or 4 actually, is gonna give result 1.5 times 10 to the third kilojoules. Cancel, 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 and then we just do the math. 2.5 divided by 55.85 times 1.7 times 10 to the third. That's 76.09 or 76 kilojoules. That are gonna be, oh, not capital by the way, it's lowercase, just in case you guys know. What? I might have done something wrong. Oh, we forgot to divide by 4. That's what I did wrong. My bad. Divide by 4, 19.02, or just 19. Now, what if we want to go backwards? Let's see. Let's start with writing 100 kilojoules, and per kilojoule, per 1.7 times 10 to the third kilojoules, there is 2 mole of Fe2O3 or rust, as mentioned right here. So per 1 mole of Fe2O3, there is, let's do the math, 55.85 times 2, 16.00 times 3. Add them together. Calculator time. 55.85 times 2 plus 16 times 3. That would give you 159.7. 159.7. Then we just put that in our conversion, and then we could start from there. 100 divided by 1.7 times 10 to the third is gonna give us that, times 2, and then times 159.7, 18.788 grams of rust. Or in significant figures, that's gonna be 19 grams of rust. Correct. That's it for today's video. See you guys tomorrow. Peace.